Good morning, everyone. Today we are going to present our implementation and simulation of DDR2 memory controller. This is the architecture of DDR2. Basically, DDR means double data rate flow. Here, data transferred on both edges, rising edge and falling edge. This is how look like the DDR2 architecture. These are the input commands: uh, clock, chip select, row address strobe, column address strobe, write enable. These are the banks. Three, two down to zero, 3 bits. Here shows the 2 raised to 3, like 8 banks are present. And this is how the memory looks like. Here in banks, there are a lot of memory cells. Each memory cell contain one made up of one capacitor and transistor. Here we are using sense amplifier because we are using here capacitor for storage. Hence, capacitor loses its voltage. Amplifier will sense that and make it as uh, voltage 1. This is how look like the banks are arranged in memory, DDR2 memory. This is the connection between modules. Either here user, this is the model of the memory. The controller intermediate between user and memory. Here how the command, the user commands are command valid, write enable, address and write data. From controller, we are given the signal to the memory like clock, chip select, row address strobe, column address strobe, write enable, bank bits, address bits, ODT, and the memory is fetch the data or read the data to given back to the controller DDR DQ and DDR DQSN. This is the this is the complementary of DQ. This is how the DDR2 FSM flow. First, the ideal state is in ideal state the controller wait for the request from the user. After that, activate state is open. Once activate state is open, here the row and bank are select. After some time period, TRCD means row to column delay. After row to column delay, we have to choose the column and write or read the operations. After some time delay, we have to precharge. Precharge means once the write or read operation completes, the row must be closed for the next write or read operation. Then the ideal state. Here the write operation, read operation should be.
So, in the basic FSM module, the first state would be the reset, where all the variables would be obtained 0. Then initialize would be done. Next state idle, where it waits for the commands of the user or the test bench. Next, the activation state, where activate command is executed. It obtains the bank and row addresses and saves them in the latch bank and latch row. Next, time minute would be executed, where as I said, time row to column delay. Then the actual write command would be executed. Next comes the write burst, where multiple data would be written in the banks. Next, the write wait, where after the write operation is done, time minute is executed. Next, precharge function is executed. Uh, Next would be the pre-wait, where the precharge function would end here. Next, idle, again it comes back to this stage, and then again a reset initialize is executed. Next, coming to the read operation, same as write operation, reset, initialize, idle, then activate, then TRCD would be executed. Then here the difference is that read operation would be executed where bank plus column would be done. Then CAS latency would be executed where read wait is the state. Next, the data would be captured from the banks. Next, pre-charge command is executed where again the rows would be closed for the further operations. Here the pre-charge function would end. Next, idle state would be obtained, which will be ready for the next command. So to summarize, we looked at the DDR2 architecture, the interaction between our test bench, controller, and DDR2 model, and finally the FSM sequences for both read and write operations. The main objective was to implement the DDR2 command and timing sequence in the controller and verify its operation using behavioral DDR2 model. And thank you.
The code is 2 per controller and memory device. These are the parameters given to the controller: row bits 13 and column bits 10 and bank bits 3, which 3 bits means 2 raised to 3 means 8 banks. Here also same 2 raised to 3 means 8192 possible row addresses. Our data width is 16 bit and burst length is 4 and CS latency is 4. These are the timing parameters: initialization, TRCD, and pre-charge time, waiting time. These command interfaces, these are given by the user: command valid, command ready, and command write enable. This is the complete memory of address of our code. These are the output. Command control signal: CKM clock enable, chip select, active low chip select, and row address strobe and column address strobe. These are the active low signals. Illegal active low. N means active low. Pointer open. Pointer open. These are the command control signals like clock enable, chip select means active low chip select, row address strobe, and column address strobe. These are invite. In out means these are bidirectional. It acts as bidirectional. These are the state: initialization state, ideal state, activation state, activation wait state, write brush state, write wait state, read wait, and read capture. Finally, the free state and pre-charge state and pre-charge waits. These register are used for the stored by the controllers from given the user. By default, the no operation will take place. These are the state. In initialization state, these here also, as we assign the 0010, it will take the pre-charge command. Next state is activate command. Here 001 takes activate command. Here the bank is stored in a latch bank in the registers, and row is also selected. Here the write operation takes place 010 tells the DDR2 write. Bank and address are stored in latch bank and latch column. This is the burst state and read state. Finally, this is the pre-charge states. Default environment sir, no operation irutte. The main FSM starts from here.
Here again, the latch row and latch bank are obtained from the user, which are stored. Then burst, then initialization as previously said. Next idle state. Uh, this is idle state. Then activate command. Then wait row column delay. Then the right happens here, then the right burst, then recovery, a part of the pre-charge, then again read command, and accordingly CAS latency, then the red data is captured, then pre-charge, then pre-charge wait, and then comes the model.
This is the memory of our design. These are here also the parameters are declared here: row bits, column bits, and data width, and burst length. CL means CS latency. Here input, here also we declare the chip select, active low chip select, row address stroke, column address stroke, and write enable. These four signals tells the DDR device to what command to control the sending. Here we concatenating these all together, make it as a 3 bits. Chip select is initially we make it as a 0. This is the memory of our design. This is how the row this is how row, bank, and column are selected. Like here, 8 banks, 16 rows, and 64 columns. Here we use the integer b. B means bank row column. Here I declare this. Here write controller takes place, and write bank. This is the right row and right column. Where should write in which bank we write this is select here, and which row this selects here, and column which column you have to write is selects here, sir. The same happens here also in read control. This is the memory initialization. How the memory takes place, like total 26 bits ಆಗುತ್ತೆ ಸರ್. ಅದು ನಾವು ಇದು ಇಲ್ಲಿ ಸ್ಟಾರ್ಟಿಂಗ್ ಇಲ್ಲಿ ಇನಿಷಿಯಲೈಸ್ ಮಾಡಿದಾಗ here, sir. How we divided in this is takes place in the here. Yes. This is how the FSM starts from here, activate and write. This is the read, and this is the recharge.
Test page also?
Yes.
Can you briefly tell what are all the things you are providing from test page? Before it.
Same here also installation components, sir. Both this is the DDR2 controller component installation.
Means I mean how you are providing the command and factors and data instruction.
From
All the test case will be on.
test cases ಅಷ್ಟೇ ಇರ್ತಲ್ಲ ಸರ್. We are writing task for the right hand read, sir. This is the task for the writing operation. If valid in ideal state, it request from the users. Then if valid request are happens in like command valid is one and write enable is one, the address will be right. Like their space is how the burst happens here. Like the burst length minus one, we are taking burst length is 4. In for loop, it will iterate and gives the address. This is for read task. Here also wait for the ready, sir. Once the commands are ready, the read will take place. You are calling the reset function. And we are giving the addresses from the calling the write function to give the addresses. This is another write operation. And this is
So we have implemented DDR2. We understood the interaction between the test bench and the controller, and the connections between a test bench and the DDR2 model. And finally, the FSM sequences for both read and write operations were understood. And our main objective was to implement the DDR2 commands and the writing and the timing sequence in the controller and verify its operation using the DDR2 behavioral model.